Good morning, everyone. Let me start with a hard truth we often forget. Your computer trusts everything. If a file wants to execute an exe, a script, a DLL, the system's default answer is basically, sure, go ahead. And attackers love that. Malware doesn't need permission. It doesn't need sophistication. It just needs execution once. And most breaches, they don't start with the nation state 0 day. They start with a random executable someone never meant to run. This is the fundamental flaw in the traditional security model. We try to block the bad, but the pool of bad is infinite. It grows every hour, every minute. So the attacker needs one path. We need all of them closed. Now, before we go deeper, I want to acknowledge something. The inspiration for this video came from a comment by one of you, a viewer who wrote, "Can you put out something concerning software that restrict applications into behaving properly?" That line perfectly captured what the cybersecurity industry has been missing. It's not just about blocking malware. It's about controlling behavior, controlling execution, controlling what an app is allowed to do in the first place. And that's when the real shift happens. Because what if we flipped the model? What if instead of trying to block every bad thing, we simply allowed one only the known good? Keep that idea in mind because it changes. Here's the paradigm shift. On the left, we have the blacklist world, the reactive world we have lived in for 30 years. It's chaos, ransomware, droppers, LOLBins, malware loaders, a never-ending stream of threats. You can never blacklist enough. You always lose. On the right, the allow list world, clean, orderly, predictable. Here, only trusted code can run, not non-goodish, not probably fine, explicitly trusted. That simple shift from block the bad to only allow the good kills entire classes of attacks instantly. Ransomware, dead on arrival. 0 days, powerless unless already trusted. LOL beans, neutered unless explicitly permitted. Fileless loader, starved of an execution path. And this philosophy works everywhere. Windows, Linux, macOS, different engines, same mindset. Application control is not just a feature. It's a security worldview. Now let me show you how application control actually works across operating systems. It all boils down to three main pillars. Interception, the OS intercepts every execution request. Windows, Linux, macOS, they all hook the moment a process tries to run. 2. Decision engine. The system evaluates the file. Is the hash known? Is it signed by a trusted publisher? Does it live in an approved path? Does it metadata match with the policy, what the policy expects? This is where most policies succeed or fail. Third, enforcement. The OS either allows it or kills it. User mode for lighter controls like App Locker, kernel mode for brutal, tamper-resistant enforcements like WDAC. On Linux, FA Policy D and LSM framework enforce rules on binaries, script, and libraries. On macOS, Gatekeeper and Notarization decide what can run, while SANA adds enterprise-grade allowing list. And the rule is always the same. If it's not explicitly trusted, it simply cannot run. This is not magic, it's just engineering, and it's incredibly effective. Okay, so if allow listing is so powerful, why do we still see bypasses? Because most deployments are weak. Attackers only know exactly where the gaps are. and they exploit them ruthlessly. Let's break down the modern playbook. LOLBins, they abuse Microsoft signed tools like MSSTA, MSBuild, RunDLL32. These binaries are trusted, so malware hides inside them. Fileless payload, reflective loaders, or in-memory execution never touch disk. If your policy only checks files, you are already beaten. Trusted certificate abuse, they sign malware with a stolen or fraudulent cert. If your policy blindly trusts certs, it's a game over. Policy hijacking, the new big one. Malware like Dream Demon weaponizes WDAC itself to disable EDR and AV. A weaponized allow list used against you. Path and script loopholes. If users can write to a trusted folders, it's not trusted anymore. And if your policy lets any PowerShell, Python, or macro run, well, attackers will find their way in. A weak allow list is worse than none. A strong one is bulletproof. Let me give you something extremely practical for you. If you are evaluating an application control solution or checking whether your current one is actually protecting you, this is the list you need to screenshot. It's the non-negotiable checklist. Let's walk through the essentials. Hash plus certificate plus path rules. You need all three. Relying on just one creates blind spots attackers love. Script control. If PowerShell, Python, JS, and macros are not governed, your allow list is Swiss cheese. DLL and library allow listing, because malware loves injecting into trusted processes. Audit mode plus learning mode. You cannot deploy allow listing without a safe discovery phase. Granular targeting, different users, different roles, different rules. Flexibility is then safety. Automatic trusted updaters. Your patching process must seamlessly update the allow list, or everything breaks. Driver or kernel whitelisting. Most modern attacks use vulnerable drivers. If you don't control them, you're exposed. Tamper protection. If an attacker can disable your security tool, you don't have a security tool. Easy approval workflow. Admins need one-click approvals without killing productivity. Centralized console. You cannot run an allow list manually, at least not at scale. Event logging and SIEM integration. This is because visibility is half the battle. Fail-safe recovery channel, because even perfect policies can lock you out if you don't have a safety escape hatch. And the rule that ties all this together is if even one of these is missing, attackers will find the gap. Before we look at what's on the market today, we need to talk about where application control is going. Because here's the reality. The threat landscape is evolving faster than the tools. Tomorrow's attacks will not look like yesterday's malware. And if vendors don't evolve, allow listing will become soon obsolete. So let me show you the next generation capabilities that will define the future of this space. Features almost no solution offers today. But every organization will need those in the next 3 to 5 years. Behavior constrained allow listing. Right now we ask, is this file allowed? In the future we must ask, is this file behaving the way it's supposed to? Execution contracts, Word that cannot spawn PowerShell, browsers that cannot touch LSAS, processes locked into the behavior they are designed for. This kills entire classes of LOLBin attacks instantly. 2. AI agent governance. Your OS will soon include AI agents that can open apps, modify files, move data. We need per agent allow listing. Rules that bind not only the users, but the AI acting on behalf of the user. This is critical as prompt injection attacks become mainstream. 3. Supply chain attested execution. This is the big one. Only binaries that appear in a signed SBOM, software bill of material, with verified bill provenance and tied to the software supply chain should be allowed to run. Hash alone is no longer enough. Cert alone is no longer enough. We need to trust where an app came from, not just what it is. 4. ML-driven policy optimization. Audit mode is not enough. We need systems that continuously learn normal execution patterns and propose optimal, minimal, safe policies. Imagine an engine telling you, block this DLL, no one has used it in 120 days, or this publisher rule is dangerously broad. Here's a safer alternative. That's the future. Built-in bypass simulator. Your application control system should attack itself every single day. Simulate LOLBin chains living off the land. Simulate WDAC override attacks. Simulate fileless loaders. Simulate path writable abuse. And give you a score. You're vulnerable to 3 out of 17 known bypass techniques. Fix it now. That's how you stay ahead. 6. Cryptographically enforced multi-part policy. One of the scariest trends today, malware abusing WDAC itself to block security products. This only happens because policy updates rely on a single signature or a single admin. Next-gen solutions need quorum-based approvals. 2 out of 3 keys required to push or modify any policy on any endpoint. This kills entire classes of sabotage attacks. And all of this leads to one idea. Application control next-gen or 2.0 is proactive, adaptive, and context-aware. Not just what can run, but who can run it, how, from where, and under which constraints. This is where the industry must go, because attackers are evolving and our defenses must evolve even faster. All right, now let's make the market simple. There are a lot of products out there, but the landscape is actually very clean once you know what you're looking at. On Windows, we have AppLocker, which is flexible user mode, great for medium rigor environments. WDAC, kernel level, brutally strong, but demands maturity and discipline. ThreatLocker, Airlock Digital, Carbon Black, enterprise grade, policy driven, more automation and oversight. On Linux, we have FA Policy Daemon, lightweight, RPM trust-based, highly effective for servers. AppArmor or Security Enhanced Linux, SE Linux, not classical whitelisting, but powerful confinement engines. On macOS, we talked about Gatekeeper and Notarization, Apple's built-in reputation model, and Sanda, true Allowlisting, excellent for enterprise hardening. The goal here is not to chase the coolest tool, of course, it's to match the engine to your risk level. Pick the engine that fits your threat model, not the one that fits your convenience. Now that we have explored the enterprise landscape, AppLocker, WDAC, Carbon Black, ThreatLocker, Airlock, I want to briefly open a different door. Because not everyone watching this channel runs a 5,000 endpoint fleet or a hybrid cloud data center. Some of you are securing your home lab, a consulting laptop, a small business server, or simply your personal machine. And you still want real protection without enterprise complexity. There's a whole ecosystem of lighter, standalone, hardening tools trusted by power users, incident response pros, penetration testers, and boutique MSPs. These are not enterprise platforms, so they don't have SIEM integration, central policy management, or governance. But in the right environment, they are absolutely devastating against malware, LOLBins, and exploit chains. Let me walk you through the key players. AppGuard is the closest you get to dynamic isolation for everyone. It blocks malware not just by signatures, not by rules, but by cutting off untrusted processes from touching trusted ones. It's brilliant on a single machine, but again, no enterprise management. VoodooShield is the smart lock of endpoints. When locked, it blocks anything not already trusted. It's incredibly effective against droppers, payload loaders, and suspicious execution paths. Perfect for desktops, consultants, and SMBs. OSArmor is a behavior blocker designed to stop exactly the things modern attackers rely on. Office spawning PowerShell, run DLL32 abusing odd paths, or LOLBins chain loading each other. It's lightweight and brutally effective, but again, not built for central governance. SysHardener is more of a OS hardening toolkit. It reduces the attack surface, disables risky components, and reinforces Windows's built-in defenses. Great for small setups, not a policy engine. Drive Sentry and legacy HIPS tools. So when you have older solutions like Drive Sentry or host intrusion and prevention, they served their purpose years ago. Some still work on niche isolated systems, but most lack modern protections, updates, or compatibility. They are more interesting history than future-proof defenses. The key insight here is these tools belong to a consumer SMB power user segment. They are simple, effective, in many cases more aggressive than the enterprise products, but they don't scale, they don't centralize, and they don't offer policy governance. Use them when you're protecting single systems or simple environments, or you want an extra hardening layer on your personal machine. But don't confuse them with the enterprise Allowlisting. They are powerful, but they are not the same weapon class. So if you're a home lab builder, a consultant, or running a few servers, these tools can massively improve your security posture. Just remember, they are hardening boosters, not enterprise frameworks. Different environments, different tools, different responses. This is where most organizations fail. Application control is incredibly powerful, but if you deploy it wrong, you'll cause outages, break workflows, and frustrate users. So here's the roadmap that actually works when implementing one. Step 1, inventory. Start in audit mode. Watch everything that runs across your environment. This is your baseline truth. Second, baselining. Approve only what the business truly needs, not what's installed, what's actually used. 3, harden. Add scripts restrictions. Block LOLBins you don't need. Remove unnecessary interpreters. This is where you eliminate attack paths quietly. Step 4, enforce. Switch to lockdown mode carefully. Monitor what gets blocked. Iterate, refine, lock down further. If you follow the roadmap, deployment becomes smooth, controlled, and predictable. And remember, good allow listing is data-driven, not guesswork. So let's bring this home now. Application control is not just another security product. It's not a feature, it's not a checkbox, it's a foundational mindset. If attackers cannot execute code, they cannot win. Whether you are running Windows, macOS, Linux, cloud workloads, or on-prem servers, controlling what can run is one of the highest leverage defenses you can deploy. If this breakdown helped you think differently about Allowlisting, please do me a favor, hit like, subscribe to the Daily Signal, and check the rest of the videos in the Strategic Signal playlist. You will find deep dives, attack breakdowns, and practical framework design to help you think like a defender and stay ahead of attackers who are always evolving. Thanks for watching. I am Max, Point Break Security, and I'll see you in the next one.